Absolute cinema. Alright, so you didn't say 7 wrong. It's supposed to be up and down.
Do you not know for your audience?
Yeah, okay, so our board questions are getting us thinking about division with monomials, so single terms. And we're going to be using this today, but we're working with for our division of polynomials. So looking at x to the 4th over x, if you guys recall, we subtract the exponents. So it's like x to the 1st. So it'd be x to the 3rd on top, and then a y to the 4th on top. And there'd really be nothing on the bottom. You don't need the over 1 part, but you could write it if you want. Then if they have coefficients, so 12 over 4 really becomes what? 3 over 1 either way. And then there's 5 m's on the top, 3 on the bottom, so it's going to be m to the 2nd on top. And again, that's just 3 m to the 2nd. And then finally, number 3, what happens with the 6's?
Cancel.
They cancel. And then the b to the 3rd over b to the 2nd, b to the 1st, right? Or just b. And you can put it on top if you want, otherwise just b. All right. So, all right, so they tell us that we're dividing 6,454 by 362. The quotient is typically like that whole number answer. And we're going to take these notes today, and then we're going to end up practicing this again tomorrow. So I get like kind of this long decimal. They want the remainder. So again, we learned last class that we don't want to leave it as 0.682. We want to talk about that remainder. And what basically that is we look and see if I multiply 362 times 17, what number do I need to add on to make it equal that 6,454? So I get 6,154. That means I'd have to add on 300. So our remainder would be 300. So this next problem is asking us to find the remainder of something that has like a polynomial. So I don't remember if we defined it, but a monomial is a single term. So all these at the top are considered monomials, whereas a polynomial has multiple terms. And so they're telling us we're dividing these two from one another. Now today we're going to learn how to actually divide these. And it's going to equal this, but it's missing a remainder. I'm just going to write r in the remainder. Kind of like up there it equaled 17 point something. We want to know what the remainder is in this case. So they want the remainder and the degree of the remainder. So we're going to kind of go backwards the way we did this one in order to figure out how close we got to the actual value. We're going to take the quotient and the divisor and multiply them together. It's going to be a bit of a pain because it's a big multiplication. So kind of like we multiply these two up here, we're going to multiply these two together. So this is showing us how close we're actually getting to that first polynomial. And I have to do FOIL here, but I kind of have to do like super FOIL. So I multiply this x squared by all of these. And then I have to multiply the -2 by all of them. To the 4. So that, right? So yeah, this goes to all 4 of those. That's where all the red one comes from. And then I multiply all the -2 times all of those to get all the purple. And we're going to put this all together. Now these guys will cancel. Minus x to the 4th, right? -1. Okay. So this is what we got when we multiplied those two together. So we have to figure out what the remainder is. So how close are we to the original amount? So comparing these two. And the way we're going to check that is we're going to subtract them. So I'm going to bring this down. And we're going to subtract these two. And that's going to show us how close we get to the actual answer, and this is going to be our remainder. Now if you look, x to the 8th minus x to the 8th is going to cancel. Negative x to the 4th and negative x to the 4th is also going to cancel because you're subtracting them, they're the same. 3x to the 2nd and minus 3x to the 2nd is going to cancel. So we're super close, but we're left with a -5 minus a -18. This is going to be our remainder. So our remainder will be 13. And they want the degree of that. Degree is the highest power on the variable. There's no variable. So what would the degree be in then? Not 1. Would that be x to the 1st? 0.
And that's from the 13. Oh, I know.
Yeah. Yeah, because it's like this. It's basically what 13 is, right? Okay. So I know there's one or a few questions in your homework like this tonight where you kind of have to work through these steps, taking the different parts that we know already and trying to find that remainder. All right. So the next thing we're going to talk about is long division. And you might wonder why we're using long division. We're going to do long division like kind of like the most basic way with actual numbers, and something you might have forgotten how to do, or maybe, I don't know, with new math, I don't know, like, I'm not too hip on all like the newest math trends in the elementary school. I don't know if they actually teach long division anymore. I think they probably do, but, so we're dividing these two. So this is rather than grabbing our calculator and dividing 7,231 by 5, I want to know what my answer is with the remainder. So I'm going to divide this way. Because we're also going to do this with polynomials. So if you remember how to do this, and if you don't, that's why we're going to talk about it, is we take it, basically we say, how many times does 5 go into 7? 5 goes into 7 one time, and I typically will put the 1 right above that 7 digit because that's what I divided it into. So that's our first step, is we divide. I'm going to kind of write our little steps out here. Then our next step is what? So, we're doing long division here?
Minus.
I think we need to do something before you minus.
Yeah.
No. We need another number down here. So we take these two and multiply them together. So 1 times 5 is 5. So we multiply. That was assumed, you mean?
Yeah.
Now we will subtract. I just want to make sure I write it down because when we start using like variables with it, I'm afraid that you might forget kind of the steps. So we're going to subtract 7 minus 5 is 2, and then I bring down that next digit. And then we repeat this whole process. So now I divide 22 by 5. Goes in 4 times, right? So now we repeat this process. So we multiply and subtract. And then drop down.
Whoa.
Where are you at?
Oh, this is hard. Yeah.
23 divided by 5 is 4 again. And we multiply. Subtract. And drop down.
Yeah. So I saw the activity and it's only 5 actions. Yeah, well, that wasn't even that close.
Right. So we have 31 divided by 5, that's going to be 6. Subtract. And now I can't go in anymore. I have no more digits. So this is where we stop. This is where we write our answer with a remainder. So this would be like, I don't know, when I wrote this, I wrote R1. So that's what I would say here. So my answer with a remainder will be written this way. There's going to be different times that they're going to ask you to write these different ways. Now the quotient remainder theorem is what we learned last class. So what that basically is saying is my original problem, my original number comes from these two multiplied together and then add that remainder on. So this is what we talked about last class. It was basically I show a true math statement. These are my parts that I know. These multiplied together. There's my remainder. The last way to write it, actually we'll use quite a bit, is called rational form, and that rational is a fraction. So the rational is basically put the remainder over what you're dividing by. So 1 over 5. We divided it by 5. So 1,146 and 1/5 is the same thing as remainder 1 because we keep dividing it by 5. So that's just another way to write it. All right. That being said, long division, the reason why we wrote that out so slowly and tried to explain it as we were going, now we're going to do that with polynomials. So algebra. Okay? And like I said, we're going to do this over a couple of days because I want to make sure you're comfortable with it before we move along. And obviously, we're going into a long weekend. We'll come back from Thanksgiving and review all this stuff. And I do have to leave early today, so I'll try to give you guys as much as I can before I have to go.
How much days straight is that?
Days straight? I think we're on like 3 weeks.
So what?
Driving bus. At
Oh my
least.
gosh,
No,
she was getting really sick. Oh, what is that?
The 50s? I think he's getting out of the hospital. Okay, so
I just love your singing.
Thanks.
all right. When I do this, one of the things that I will do that I think is helpful is I will write out, like basically I'm going to kind of put some placeholders in if something's missing. And what I mean by that, I'm going to put in so it says put in 0x or 0x to like the nth power for any missing powers of x. So what I like to do with these is I like to kind of put a little placeholder. So the reason for that is because I like to line everything up very nicely. I try to keep this neat. And if you look at this problem, I have 4x to the third, but there's no x to the second, like if I'm going down, counting down. So there's something missing there, so I'm going to put in like a 0x to the second. So it goes 3, 2, 1, 0. So I have like a place or like a decimal place for that, even though it's not really there. And I think that just saves frustration with this. It's not necessary, but again, I just, at the end, what I wrote x to the n power is because like whatever power of x is missing. So this is going to be based off of like whatever is missing.
I kept saying, is that an N?
Yeah, it is, sorry. All right, on the outside, I'm going to divide here. Okay. So we're going to use the same steps we use in long division. We're going to start by dividing those first two terms. So, and when I do this, I'm going to show it like off to the side over here. So I'm going to use like a little thought bubble kind of.
Why do you have to put in the plus 0 x to the 7?
I put it in there because I like my problems. No, it's okay. I like my problems to be all lined up. So like when I'm doing this, like everything's in a nice line. If I don't put that 0 in, there's going to be kind of like a number I try to put between those two that's going to like be like, it's just not going to be lined up with what it's subtracting from. I can show you kind of what it looks like if I don't, when we're done. Why don't we try it this way and then I'll kind of show you what it would look like. What?
Not that big of a deal.
It's
I
okay.
never said it was a big deal.
I just
explained to us already.
I just think it is helpful. This is me trying to troubleshoot to make this less difficult. So it's just me knowing ahead of time that it might be helpful. I have a little bit of an inside scoop on this. All right, so we're going to start by dividing. And when I divide, I'm going to underline what I'm dividing here. I'm just looking at those two terms only. I'm going to kind of ignore everything else for right now. And I like showing it what I'm doing over here. This is, oh, not 4. A little thought bubble. So this is what I'm thinking. So I'm dividing those two. And this is why we did the warm-up we did. So 4x to the third divided by 2x, what's that going to be? 2x squared, yeah. And now when I go to put that in my problem, I'm going to put that on top here. Now you could put it above the x to the third, above the x to the second. It doesn't really matter to me, but I usually like lining up. So this is kind of what I'm talking about, Mason, is I like to have like a line for x to the second there. And you'll see in a second why that's going to be helpful. Okay. So that's our first step, divide. Next step is multiply. So that 2x to the second is going to get multiplied to each of these though now. It's like being distributed. And I'm multiplying 2x to the second times 2x, so that should be 4x to the third. And so if I did this correctly, those first two terms should always match up. But then here's why I put that 0 in there. Because if I do 2x to the second times 1, I'm going to get 2x to the second. And if I hadn't put that 0 there, I would have been trying to smush this all together like before the next term. Like, so it would have looked, I think you'll prefer it this way. So if I had this, I'd have this 4x to the third, and then I'd have 2x to the second, but these two don't match up, so I kind of have to say, well, wait, what am I subtracting from there? That's why I think it makes sense, but it's hard to know that until you actually done it. So we multiplied. Now we're ready to subtract. And again, if we subtract this correctly, those first two terms will always cancel. But when we subtract, put parentheses around it. So we're subtracting that top row minus the bottom row. So these first two will always cancel, so that's nothing. So I wouldn't put a 0 down there, I just kind of like, it cancels. But the second term, I'm doing 0 minus 2. Those are our like terms. 0 minus 2 is going to be a negative 2x squared. So again, if we had to put the 0 in, I think you would have had to think 0, and why not just write it? And now our next one is drop down. Okay. So we're going to repeat. We go back up to the top. So I'm going to divide, but now I'm dividing this by this. So this is what we're dividing.
So it's only the first term.
Mm-hmm. Yeah, so negative 1 x to the first, or as x. And again, I'm just going to put that up on the top. And now we need to multiply, but it's this that we're multiplying. So we're taking this and multiplying it to both of those.
Wait. Oh. Okay.
The new thing. And again, if we know we're doing things correctly, those first two terms should always be opposites or be the same and they'll cancel.
Wait, so we'll multiply negative 1 to the negative 2x squared?
Negative, so we're multiplying this over here.
Oh, yeah. That's what I thought.
So negative 1x times 2x is a negative 2x squared. Negative 1x times positive 1 is a negative 1x. And so we're going to subtract. And I like to use parentheses so I don't forget to subtract the whole thing. Again, since I did this correctly, those two should always cancel. 7 minus a negative 1. 7 minus a negative 1. Yeah, it would be plus 1, so 8x. And we still need to bring down the next term.
So before we're up next.
What?
Before we're up next.
Do it one more time here. And we, oops, I guess why did I do that? I changed what I was doing. So this now is being divided by that. So 8x divided by 2x. 4. And then it's to get multiplied to both of these. Again, if you need to draw the arrows, you're multiplying here. Then we have to subtract. 8 minus 8 cancels. Negative 4 minus 4. Negative 8. So that's going to be, now we stop now, and you might wonder why, but if I try to divide negative 8 by 2x, I can't do that.
And we're getting the 8x.
The 4 up here times 2x, right? And this is now our remainder. We can't go in anymore because if I try to divide negative 8 by 2x, I'm going to get negative exponents and we don't want to deal with that. So this is our remainder. And I think a lot of times in our homework, they'll ask us to write it in that rational form. So I'm going to do negative 8 over what we're dividing by. That's our remainder. So this is our answer up here.
Wait, what is it? Negative.
So you take the remainder and you put it over by what we're dividing by. So like last time it was like 1/5 because we were dividing by 5 and the remainder was a 1. But now we're dividing by that 2x plus 1.
And that's for every single one?
Yeah, unless they tell you to, unless there's no remainder, I guess. All right. So I have time to do one more with you guys, and I want to show you guys another one. But realize tomorrow we are not learning anything new. We're just doing more of this. So like, if when I leave, that if you have questions, please feel free to, like I said, we have the middle school teacher coming in, but I don't know that this is something she's done for a while, or if you haven't done this recently, I don't know that you're like, sweet, polynomial long division, let me jump right in with that. So just know that it might be something that we have to just wait for questions. And sometimes you guys troubleshooting together will be helpful. Okay. So we're gonna do this long division. This is a huge one. Now before I start, do I have any missing powers of x? Look at the original thing I'm dividing. No, 6, 5, 4, 3, 2, 1, 0. Don't need to worry about any missing powers of x. I would always check that first. This is a very long one, and that's just so we can get practice with it. That's what she said.
Why is it so long?
It's just long so we can get in the habit of doing all the steps. Where's my innocent grin?
Ethan's wrong, so he's saying that.
Yeah.
I don't know the last time I said that.
After I say something, I'm like, crap, I just realized that it's like
Trigger.
yeah. All right, so. And again, I want us to practice one that has all these steps and we just kind of get used to it and just. So when I divide these two, what do I end up with? And I like putting it above the other x to the fourth just to keep everything lined up. You don't have to. Where you put the answer doesn't really matter. I just put it there to line things up.
Is there this on the folder?
Yeah, this one, starting there and working our way over. Yeah. Okay, now divide. We have to multiply. We're taking this and we're multiplying it back to both of these, remember. Again, just trying to practice all these steps. We're multiplying back. So what did you guys get when you subtracted here?
You get 24x with it.
Very good. Do you guys agree with that? Yeah. So you're taking that negative 20 and subtracting 4. So that's what the negative 24 comes from. The 6x to the 6's will cancel. And then drop down. Okay. You okay? All good? All right. Look at this next one we're dividing here. What do we get when we divide this one? Okay, good. And that's why I like doing something like this. It'll click eventually. What do we get there?
You get negative 8x to the third.
You guys are working faster than me. Some of you are working maybe a little bit slower. To multiply that back. And again, this is being multiplied to both of those. Cancels. -7 plus 16. So 9, right?
Just like looks like so much.
Because it is.
Wow.
I'm afraid for times like this.
So we're dividing those two. Maybe still doing okay?
That's weird.
When?
Hi. You walked into polynomial long division.
Oh, I'm so excited.
And we had a few absences, so.
Yeah. Actually, a few more I would have.
You feeling better yet? Oh.
We could always run for things.
Yeah, right. Yeah, no, it's.
Dude, I can see that, yeah.
I do still like a regular computer that do like my word processing, but like for. Mhm. You still hanging in there?
Yeah, it's just a lot of work. I like numbers.
Are you guys still doing good over there?
So my kids were complaining about 0 equals -6x.
Oh, right. Oh my gosh. Where did we get plus?
Where we get plus x from, because we divided, oh, did I not show that one? I don't think I showed.
Oh, can we do 3x?
Sorry, I didn't show my thought bubble over here.
I'm not there yet.
Yes, I would agree.
Okay, thank you.
And usually, honestly, you guys, I check the remainder on these long problems. If your remainder's right, probably the rest of it's probably right, which is, like, so I.
Okay, so it's that, and then you times it, and then you get 3x.
I'll move on.
Yeah. Not quite. So we can still divide, I think, one more time here, maybe. Right? So we're going to divide this guy by that. For the sigh, you're done. Decker, you got through it. What's your remainder?
7.
Yeah.
That's what I got too.
Perfect. What'd you get when you divided these two? Did you do that yet? Yeah, 1.
And you go over and
Give any space left.
I always forget to multiply. Because I forget to put it up there.
And that's why, like, we chose one that was so many steps, so that maybe you like dig it in. Yes. Yeah, the homework will be better, hopefully. All right, so I think these both cancel, but we still have to drop down. And that's just our remainder then.
Oh, really?
We did all that work.
All that work for Larry just to be that?
Oh, it's not all, it's all that.
So I could have just been.
All that fabulousness. I know, right? Yeah, she's right on it. I'm sure Griffin's not.